Valence electrons and the octet rule. What is valence electrons? Valence electrons are the outermost electrons in an atom, and they are involved in bonding. Well, what's the outermost electrons? The outermost electrons are the electrons in the last value of n, which is your principal energy level. So for example, if I have fluorine has 9 total electrons. The configuration is 1s2, 2s2, 2p5. So how many n values do we have? The principal energy level values. We have 1 for 1s2 and 2 for 2s2 and 2p5. Which is greater, 1 or 2? 2, right? So how many total electrons are there in anything that starts with 2? Well, there is 2s2 and 2p5 for a total of 2 plus 5, 7 valence electrons. What about something like sodium? Sodium has 11 total electrons and its electron configuration is 1s2, 2s2, 2p6, 3s1. What's the largest n there? That's 3. And we only have 3s1, so how many total valence electrons? Only 1 valence electron. So valence electrons, counting valence electrons is very important because they are the electrons that will be involved in making chemical bonds. Chemical bonds are how we convert elements into compounds when one element makes a bond with another element. When you apply the counting of valence electrons to noble gases will have 8 valence electrons because their electron configurations will always end in s2p6. For example, neon will have 1s2, 2s2, 2p6. Argon will have 1s2, 2s2, 2p6, 3s2, 3p6. So it always ends in s2 and p6 for a total of 8 valence electrons. And when there are 8 valence electrons, that's when the element is very stable. Noble gases, if you recall, I mentioned previously that they are unreactive. They are very stable. We call them noble because they refuse to participate in bonding with others, with other compounds, with other elements. And we say that they are inert because they don't readily bond to other elements. Because that the reason behind it is because they have a valence of 8 electrons. And that's what gives birth to the octet rule. The octet rule states that elements usually react in such a way as to attain the electron configuration of the noble gas closest to them in the periodic table. So the reason why any compound forms is because the elements want to become like noble gases, the other elements which are not noble gases, that is. And they want to become like the noble gas closest to them on the periodic table. Elements which are on the right side of the periodic table will move forward. By forward meaning that the atomic number increases, and that's the direction. To the right they will move to look like the noble gas over there. While the elements on the left of the periodic table will move backward to the left and decrease in atomic numbers. That way they will come to the noble gas closest to them. Whenever we say elements move forward or backward, what we mean is that the element moving forward will gain electrons. So for example, oxygen has 6 valence electrons, 1s2, 2s2, 2p4. The 2s2 and the 2p4 combined is 6 valence electrons, p2 and p4, 2 plus 4, 6. It wants to look like the noble gas closest to it, and it's located on the right side of the periodic table. Have a look at the periodic table to verify this. So it will move to the noble gas on the right side, which is neon. and it must gain 2 electrons. So oxygen can become like the noble gas neon by gaining 2 electrons. What about sodium? Sodium with 11 valence electrons. It's on the left side of the periodic table and it will move backward. It needs to move only one step to look like neon. It will lose one electron, and when it loses that electron it will have 10 electrons, which makes it have the noble gas configuration of neon. So elements in families other than the noble gases are more reactive, as we just stated. Noble gases are not reactive and they strive to achieve a more stable electron configuration where their S and P sublevels are completely full. When that happens, we say that they have achieved the noble gas configuration. Whenever an element gains electrons or loses electron, it becomes charged. Remember that in an atom, the number of protons equals the number of electrons. 10 protons for 10 electrons, 20 protons for 20 electrons. What happens when an atom has 10 protons and 10 electrons and loses 1 electron? If 1 electron is lost, there is charge imbalance. Now there is a surplus of positive charge. Plus 10 positive charge, but only minus 9 negative charge. So what's the overall charge? If you know the simple math of adding plus 10 with negative 9, the number is plus 1. So now there is a surplus of plus 1. Whenever an atom loses electrons, it gets turned into a positively charged species, which we call ion. Ions are electrically charged particles that result from the gain or loss of one or more electrons by the parent atom. Sodium, we stated earlier, wants to lose 1 electron and become like neon, shown here in this equation, a chemical equation of the sort, which we'll talk about later. Here what we have is sodium with a plus 1 charge. 1 is known by default to be present whenever we write just the symbol plus. So Na plus means sodium with a plus charge, 1 plus charge, and we call this the sodium ion or cation. On the other hand, if atoms were to gain electrons, they become charged as well, but this time there is a surplus of negative charge, and the total negative charge is also shown as a superscript to the right of the element symbol, and 1 does not need to be shown, 1 is known by default. So fluorine here with a 1 minus charge is called the fluorine anion. So there are cations which are positively charged and anions which are negatively charged. Previously we said that metals tend to lose electrons when we were describing metals, and non-metals tend to gain electrons. So on the periodic table on the left side we have metals, and those metals will lose electrons. So here we have sodium losing an electron to become the sodium cation. Here is the original sodium electron configuration in the shorthand version, neon square brackets followed by 3s1. When it loses 1 electron, it has the configuration of just neon, which ends in 2s2 2p6, which is a full octet of 8 valence electrons. Anions gain electron, non-metals on the right side of the periodic table tend to gain electrons to achieve an octet. Oxygen has the configuration with 8 electrons of 1s2 2s2 2p4, and these are the valence electrons, 2s2 2p4. It will gain 2 more electrons, and when it does, it will have a charge of 2 minus. Whenever the charge is greater than 1, we need to specify that by a value shown here. So oxygen with a 2 minus charge would then be given the configuration of helium in abbreviated or shorthand version of helium in square brackets followed by 2s2 2p6. Has oxygen anion now gained an octet of 8? Yes, 2s2 2p6 tells you it's an octet of 8. So keep this in mind, that metals want to lose electrons and non-metals want to gain electrons. all atoms of a group lose the same number of electrons. Within a group such as group 1A, all the metals will lose one electron. In group 2A, all the metals will lose two electrons. Group 3A, such as aluminum, will lose three electrons as long as they are metals, because as we go down the group 3A, and you should see that on a periodic table you should have before you, you will see that going down aluminum we arrive at metalloids and ultimately into territory of very heavy elements which are not very stable. So aluminum has this configuration of neon followed by 3s2 3p1. It must lose 3 electrons, and when it does that it becomes the aluminum cation with 3 plus charge and the noble gas configuration of neon. What about transition metals, the ones in the middle, the large band starting with 3b? What about those atoms? Well, they also are metals, and because they are metals they tend to lose electrons to become cations, but predicting the charge is not easy as stated here, because they can form more than one kind of stable ion. They can lose more than one specific number of electrons. For example, iron, which is Fe, can form these two ions, Fe2 plus and Fe3 plus. Okay. And other ions can have more than two. You do not need to memorize any of them, but if you study chemistry more, many of it will just become your everyday routine work, and you will henceforth end up memorizing them. Give the charge of the most probable ion resulting from these elements, calcium. Look for the location of each of these ions, and if it's in group 1, each of these metals, and if they are in group 1A, they will lose 1 electron. If they are in group 2A, they will lose 2 electrons. If they are in group 3A, they will lose 3 electrons. What about group 4A, starting with carbon? Well, technically they can either lose 4 or gain 4, but neither of that happens to them. They do not form the kind of ions that you normally see. They behave differently, and we will cover that in chapter 3. But then group 5A. 5A has 5 valence electrons and they need to gain 3 more. So they will gain 3. What about group 6A? They will gain 2. And group 7A, they will gain 1. So the way it goes is loss of 1 electron followed by loss of 2 followed by loss of 3, going from group 1A, 2A, 3A. Then ignore group 4A, then we go in the reverse direction. Gain of 3 electrons in group 5A, gain of 2 electrons in group 6A, and gain of 1 electron in group 7A. Figure out what kind of ions this would form. Now, which of the following pairs of atoms and ions are isoelectronic? Isoelectronic means they have the same electron configurations. So chlorine minus, or chlorine 1 minus, and argon, sodium 1 plus, and neon. Write down the electron configurations of each of these pairs and see if they are the same after some of these atoms have gained charges, or by accumulating electrons, or by losing electrons. If they have the same electron configurations, we say that they are isoelectronic to each other. So now here is another question. How many protons, neutrons, and electrons are in the following ions? And we previously learned how to write this symbol. This here is the atomic number, which is the number of protons. This here is the mass number, which is the sum of protons plus neutrons. So here 39 minus 19 gives you the number of neutrons, which is 20. What about the number of electrons now? Normally we would say that the number of protons and electrons would be equal. So we would say that if there are 19 protons, there are 19 electrons. However, potassium has lost 1 electron because of plus 1 surplus of protons. So 1 electron gone out of 19 means now there are 18 electrons. Remember that when it comes to plus charge, we are not gaining protons. In fact, we cannot gain protons. That would change the identity of the atom. But by losing electrons, we carry a plus charge. Find out how many protons, electrons are here in this ion and in this ion as well.